You're totally right. We've done Pythag a ton. But now here's what I want to do. I want to relate it to geometry. And then I also want to show you a different use of Pythagorean theorem than what we've been using it for. All right, so here you go. A squared, B squared equals C squared. Number one thing, I haven't mentioned it. I don't think I've mentioned it. We just go with it. We just roll with it when we use it. This only can be used in what type of triangle? A right triangle. Yeah, you just can't use it for any triangle. Like if I just throw some rando triangle and say that's 2, that's 5, what's this side? We're not using Pythag. Okay? Honestly, I don't know how we're doing that. All right, we're not doing Pythag because it's not a right triangle. So I need a right triangle. Next up, I just want to make sure we know what each piece means here. What's the C? And use your vocabulary here. C is for the hypotenuse, whatever the hypotenuse is. And then A and B, what do I call the other two sides in a right triangle? Those are the legs. Okay, those are the legs. C is always the hypotenuse. So let's relate it to geometry now. I got a parallelogram up there. Find the perimeter. All sides added up, right? All sides added up. Well, we just finished the quadrilateral unit a couple weeks ago. One side's 11. What other side do you automatically know now using parallelograms? 23. What other side? One side's 11.
The opposite side.
Good vocabulary. Opposite side is also 11 feet. Opposite side's congruent. Now I just got to figure out the other two sides, right? And I can do that using, everyone see the right triangle we built here on the left? Using Pythagorean theorem. Okay, using Pythag. So let's do that. Where should the 6 and the 2 go of that right triangle? In for A, B, C, let me know. 6 and 2, where's it going? 15?
They should be
Good. 6 squared plus 2 squared equals C squared. Go ahead, keep grinding. Oh, sorry, you're fine, Molly. I meant the class. 36 and 4. C squared equals 40. Yep, go ahead. It says simplest radical form, so break it down for me. Hopefully we're getting better at this, breaking down radicals. When you're ready, what's 40? Square root of 40 breaks down into 2. Nope. One more time. 14. Nope. 2. Nope. 19. 2 radical. 10. Do we have a 14 in here, by the way? No, we don't. Correct? All right. Because every class is different. I don't have one of these in first period. I don't have one of these in second period. So 2 radical 10. Which means the other side is 2 radical 10. All right, you ready for the perimeter? Because I don't know how much you did radicals last year in algebra or how much you picked up on it with the way last year went. Ready, perimeter. But it's not an excuse anymore. I got 2 radical 10 plus 11 plus 2 radical 10 plus 11. Ready? What can we, because you cannot combine all 4. No shot. You can't combine all 4. You can combine the 2 11s to give you 22. Now notice the radicals that are left. Is the number underneath the same? The number underneath the radical, do they match? That means you can add them. If one was a 10 and the other was a 7, we can't add them. What's underneath needs to be the same. So if I have 2 of these and 2 of these, how many do I have total? 4. And you keep the radical 10 the same. You don't make it radical 20. That's not how we add radicals. You just add the number. Hey, think of it this way. You have 2x and 2x. What are you going to tell me? 4x, not 4x squared. Right? You're going to tell me 4x. That's the same thing with radicals. Just add the numbers out in front. And this might be painful for a lot of you, especially on your experience last year in Algebra 1. All right? But again, I don't want to use last year as an excuse anymore. 22 plus 4 radical 10. Can I combine these two now? No. What's missing from the 22? A radical 10. So you can't combine them? This is it, guys. This is the perimeter. 22 plus 4 radical 10. That's as far as you're going. You can only add and subtract radicals when the number underneath is the same. Any questions there? All right, because this is where it's going to be a pain in the butt. I'm telling you, is the whole algebra part of it. Forget about geometry. All right, let's go to Big Al and help him through the pond. He doesn't want to walk through the pond. That's a good idea. So to avoid the pond, he's going to walk, let's see, 34 meters south, 41 meters east. Do I need to put the compass up here? We know our directions, right? So to avoid it, he's going to go, ready? 34 meters, whoop, south, down. And 41 meters to the east, right or left here? Right or left? Right, and that'll be 41. And connecting those is your pond, right? There's your pond. Woo, good, there's the pond. So if Big Al could walk through water, and he did just walk through the pond, how many meters would he have saved by just walking through the pond? Well, right now, how many, by not walking, ready? Let's answer this question first. By not walking through the pond, how many meters did he just travel? By not walking through the pond to get to his finish line, 75, right? Everyone's good there? 34 and 41. So I'm just going to make a note off to the side. No pond, 75 meters. Everyone see how we got that? 34 and 41. But what if he could walk through the pond? How can I find how many meters he would have traveled through the pond? I can use Pythagorean Theorem. A squared plus B squared equals C squared. Where are the 34 and the 41 going for me? 19. Good, A squared and B squared. So 34 squared plus 41 squared equals C squared. If you guys have read the problem, you'll notice I don't say simplest radical form for this one. But I am going to get fired up here in a second, so just prep yourself. I get 2,837 equals C squared. Everyone with me there? All right. Question for everybody. When I take the square root of this number, is that going to be my final answer? The length of the pond, is that my final answer? No, it is not. And I'm asking you this for a purpose. When you take the square root of 2,837, and it is not your final answer, you're not rounding that. We don't round anything in here until the very end of the problem, and since that's not my final answer, I'm not rounding it. I'm writing it all out. So here's what we're writing. The length of the pond is 53.6349594. We don't round squat in this class until the very end of the problem. And I'll tell you why at the end. So that's not our final answer, so I don't round it. All right, so 75 meters to not go through the pond, 53 and change to go through. How do I find out how much he saved if he could walk through the water? How do I figure out how much meters would have been saved if just going through the pond was an option? One, hi George.
Subtract 75 from the 53.
Darn right. There you go. Subtract 75 in your length of the pond. Good work. Now, will this be my final answer? Yes. Now you can round it to the nearest tenth. So if Big Al could have walked through the water, he would have saved what? 21.7 meters. 21.7 meters. Oh, Here's what, and again, I always want to tell you, when I tell you to do something, I want to tell you why it's being done. You round this number we got for the pond, you might have got 0.6 as your answer. 0.8. It's wrong. All right, that's what happens when you round in the middle of the problem. It throws off your final answer. All good. So don't round to the end. Questions? All right, let's go. Looks pretty basic, right? Wait till you hear and feel the algebra that's going to come off this one. All right, it's a right triangle. I know all three sides. Let's do Pythag. You tell me what goes in for A, B, and C right now. Let's do this. Whoop, 12. You let me know what should go in for A and B.
8 and
Yep.
x minus 4.
8 squared, everybody, plus x minus 4 squared equals, and what about C, Luke? X squared. So take a little peek at that before we do anything else. We all good on why it's A, B, and C like that. Good job, Luke. All right, 64, that's not a big deal. All right, here's where it is a big deal, and this drives me nuts. And it's not your fault yet unless you do it on the quiz. X minus 4 all squared. What the heck do you do there? It's not x squared minus 16. Hate to break it to you, your algebra teachers are crying right now hearing that. Ready? X minus 4 squared is the same as multiplying it by itself twice. All right, we all good? So I don't get fired up on the quiz if that happens. You just multiply. Now, double distribute. We did this last unit. Whoop, whoop. Boom, boom. Go ahead. I'll ask somebody what you got here after you're done double distributing. X minus 4 all squared, double distribute. Don't wait for me. Combine your like terms. What? I'm not ready there. We'll get there soon. All right, let me know what you got when you double distributed there. Just right, that's all. Don't combine it with the 64. What did you get here? All right, what did you get here? I want to make sure everybody can do this. 16, what'd you end up with?
X squared minus 8x plus 4 y combined with 16.
So plus 16, right?
Yeah.
Okay, good. Good job, Carter. There we go. So that's what I get when I double distribute FOIL. Combine like terms. Go ahead. 64 and 16. Plus 80. We're all on the same page. We're all good. Now, I know anybody think it may be factoring's coming up here because you see the x squared? Me too. I think factoring. But last unit, we can't factor unless what happens? Equal to 0. It's got to be equal to 0. And I know some of you are getting uncomfortable right now because to get it equal to 0, what do I need to do with this x squared? Okay. Here's why you're getting uncomfortable. What's going to happen with my x squareds here? What's going to happen? See ya! They're gone. Okay. Deal with it. Let's deal with it. What's left? Negative 8x plus 80 equals 0. Don't overthink it. You guys can solve that. That's a basic algebra equation right there for you to solve. Get x by itself. Go. Get x by itself. No factoring needed. Just get it by itself. Move the 80 back over. We got it. We got it. So x ends up being 19. On fire today. 19? Who's got 19? Number 19? Zach, are you 19?
Oh, yeah.
We all right?
Yeah.
Hi. I'm school. Have we met?
X equals 10.
10. Thank you. You're all right over there?
I just need more time to stay than the rest of the year combined.
Hey, I told you that's the wonders of the generator. All good. 10? All right. Hey, some hardcore algebra there, and I'm not shying away from it. I'm not shying away from it. If it's too much for you, you know the deal. This is the type of class you signed up for. Any questions? All right, so that's Pythag right now as you know it. Find a side. Let me show you another use today, and this is how we're going to end the notes. Another use of Pythag. Believe it or not, we can use Pythag to tell me if a triangle is acute or obtuse. Whoa, time out. Usually you need what to figure out if a triangle is obtuse or obtuse? Not sides, but angles, yeah. Not anymore. If you tell me the 3 sides, I can tell you if it's obtuse or an acute triangle. Here's how. And you don't need to write this down. I'm just going to basically blow this up what's on your paper right now. You figure out what a squared plus b squared is. You do number crunching, put it in your calculator. If that number is bigger than your c squared value, this bad boy is acute. All right? So after you calculate a squared plus b squared, ends up being bigger than your hypotenuse squared, it's acute. And the opposite is true for obtuse. You do a squared plus b squared, and it's actually less than c squared, it's obtuse. That's how we can figure out. Now, whoa, aren't I missing a scenario here? I got greater than c squared and less than c squared. What scenario am I missing here? Equal to. Well, what if they're equal? You've been doing that all your life.
That's right.
What type of triangle do I need for Pythag? A right triangle. So if they end up being equal, it's a right triangle. All good? All right, so let's try out. I got 2 examples here before we end on the big one. A triangle's got lengths 9, 12, 15. What type of triangle is it? Whoa. I need your help with something. I'm not going to put equal to c squared because I don't know the relationship. What do you plug in for a and b now?
Smaller.
You plug in the smaller 2 sides, yeah. 9 squared plus 12 squared. How does it compare to 15 squared? Crunch them up. That's what you want to figure out. A squared, b squared, how does it compare to c squared? So a squared and b squared came out to be 225 when you added them together. And 15 squared came out to be 225. Oh, if they're equal, that means it's a right triangle. Yep, this one, if you have sides 9, 12, and 15, it is a right triangle. Great use of Pythag. All right, go ahead on your own or in your groups. 10, 11, 13. 10, 11, 13. What type of triangle are you working with? Smaller 2 sides go in for A and B, larger side in for C. How do they compare? So you got 221 for the a squared b squared, 169 for the c squared. So the a squared b squared was bigger, meaning what type of triangle am I working with here? 10, 4. Good, acute triangle. Good work. And one more of these now. What happens if I throw it on a graph and I want to know what type of triangle it is? Not going to like this one. Oh well. Oh well. So go ahead and graph it, and we'll talk through it. Alrighty. There's no way you're going to figure out what these angle measures are. No way to figure out if it's obtuse or acute on the graph. No way you can tell me how many degrees. But you can tell me what the side lengths are so we can plug it into Pythag and figure it out. How do I find the side lengths then? Distance formula. So here's what I'm going to do so you don't have to do 3 distances. We're going to break the class up right now. All right, we're going to break the class up. I'm not going to tell you what the distance is. That's between you and your group to decide. All right, we've been over that one quite a bit. So this little column right here, you guys have xz. You're responsible for xz. Do not break down the radical if you can. Leave it. Group in the corner there. I'm going to let you guys do yz for me. And then my final 2 groups right here, you guys are going to do xy for me. Okay? Do not break down the radical. Just leave it underneath. That's it. You're just doing xz. That's it. The rest of the groups will do the other 2. Thanks, Mike.
Take care.
You too. All right, so remember the distance formula.
It's hard. It takes up so much time.
Even if you can break it down, don't break it down. I'll tell you. You'll see why here in a minute. Okay, please jot down the rest of the side lengths if you weren't responsible for the one we're talking about. XZ, our group right here, XZ, what'd you guys have? Square root of? 13, good job. Square root of 13 is XZ. Make sure we jot it down, everybody. YZ group in the back there, what do you have? Oh. Okay, leave it radical 20. All right, leave it radical 20. That's fine that you broke it down, but just leave it radical 20 here. And then my XY group, what do you have? Radical 29. All right, here we go. Now that I know the side lengths, let's use a squared plus b squared and compare it to c squared. What are the 2 smaller sides? Radical 13 squared and radical 20 squared. How do they compare to radical 29 squared? And this will, you can go to go to your calculator real quick. And you'll see real quick what the pattern is when I square a radical. If you do the square root of 13 and square it, what do you get? You get what? 13? Oh, If you square the square root of 20, you end up with, are you seeing a pattern here? If you square any radical, you just get the number underneath. So 29, how do they compare now? 33 and 29? All right, so I see the a squared plus b squared side is bigger. So this is going to tell me it's a, what type of triangle now? 9? Never mind. 5? Maybe one day. 12? Acute. Questions? I am going to leave this last one for you and your group to discuss. I have 2 right triangles. We got Big Al, says they're congruent. His brother, Little Mike, says they're similar. Are they both correct, or one's correct, neither's correct? Discuss it. You might want to find the missing info. Are they first in your group? Discuss, are they congruent? Yes or no, and why? And then discuss, are they similar? Yes or no, and why? All right, go ahead.
They're congruent. Yeah, they would be congruent because this equals 13. You guys would have gotten congruent.
Yes, because then this is B is 13.
Yeah. So if they're only congruent, they're not.
Wait, no. So it's only big.
Oh,
Is it only big powders correct? Because if they were similar, then I would be like proportional.
we just need to go side by side.
So everybody found out I got 13 for this hypotenuse, 12 for this leg. Are they congruent? Here we go. Are those 2 triangles congruent? 6, are they congruent?
Yes.
Why?
Because the side is
You got a method for me maybe then?
side.
Okay, they are congruent because of side, side, side. Remember that one? Side, side, side. You could also say what? Side, angle, side. Everyone see, because I got the right angles, you could say side, angle, side. Are they similar? 20? Why? That they are similar because if they're congruent, they're similar. Or anybody go side, side, side similarity. Side, angle, side similarity. They're all in the same ratio, 1 to 1. So they are similar because, and I'll use Addie's response, they are congruent. Any triangles that are congruent are also similar. Grab your calculator. I want to make sure we are solid for tonight's homework. Tonight's homework, you're going to get fractions. and it's no excuse not to do the problem. Are we comfortable in our calculator doing this? 3/4 squared plus 5/8 squared. We're all good there? You go to alpha y equals and put it in a fraction template. We should have no issues. We're comfortable with that. Everybody, yes? Okay. You'll also see a problem tonight that looks like this, though. 3 1/4, 2 5/8. Find the hypotenuse. You can put this in your calculator. I don't know if you ever have before. Go to alpha y equals again. Usually you guys choose number 1. If you want to put a fraction in like 3 1/4, you choose option 2. And everyone see you can plug those in right there. Okay, so no excuses tonight when you get to these fraction ones. You know how to, you can use your calculators. Just go to alpha y equals. Questions? All right. Well, one last thing. Your textbook does not have rounding directions. Bottom of the page right here. I tell you what to round to. All right, because your book's not going to have the directions there. So pay attention to what I'm asking you to round to. All right, thank you.